Hello everyone. Welcome to question 6 of Placement Test Series 1. This is Nikesh Agarwal from Sarthi Career. This question is on recursion and storage class specifiers. Recursion is one of the super hot topic in the interviews. I have myself encountered this question at least 2 to 3 times in the early stages of my career. With that being said, we will first solve this question without the keyword static and then with the keyword static in it. This will help develop a better understanding on the topic. On the right, I have drawn part of RAM memory for this program. So this being stack memory and the below part is your data memory. Now I'll not be speaking too much about stack in this video. I will just provide enough information to solve this question. In the future, I'll be uploading a detailed video on the stack memory for your better understanding. Now on the left hand side, we have this code which after compiling by the compiler, it will go as machine instructions, or it will make a machine instruction file which will be eventually executed. Now all these statements have some address in the code memory. Okay, so let's give it some address. So this being 0x00, this is 0x02, this is 0x04, 0x06, 0x08, and finally the end of the code, which is 0x0a. Now this is a very rough explanation on the addresses, not very important, just enough to understand this question. Now these are the addresses. Now the CPU architecture has a counter or a register which is called the program counter, which is basically pointing to the current statement which is being executed. When we start off with running the code, the program counter is pointing to 0x00, which is basically your void main. Right? Now whenever a function is called, in the stack memory, a stack frame is created, okay, for that particular function. So this is stack frame for main function, and we will call it main_1, indicating that this is the first instance of the main function. Now stack memory is used to store local variables, arguments of the function, return addresses of the function, and few other related info, and it follows a LIFO policy, which is last in first out, or you could rather put it as first in last out. So whichever is the first function called will be the last one to exit the stack memory. And when when the function gets over, this particular stack frame which was created for the function gets destroyed. The stack frame is also called activation records, which basically contains records of all the local variables, arguments, and other kind of variables which are used in that particular function. Now in this question, we see that the first statement says I equals to 5. So we create a variable I in the stack with the value as 5. And then we see if of minus I, which is a pre-decrement operator, which will change the value of 5 to 4. And if you see here, if of 4, so by default, when you don't have any comparison statement, the compiler automatically appends not equal to 0 along with the if statement. So it will treat it as if 4 not equal to 0. Yes, 4 is not equal to 0. So it goes inside the if statement and it prints the value of I, right? So what is the value of I here? The value of I is 4. Okay, so it goes and prints that. And then it sees a call to another function, right? You can understand the syntax for a function. So it calls another function, and now it just so happens that this function name is the same name as the main function, and this is recursion. Whenever any function calls itself in it, it is called recursion. Now recursion is no different from calling functions from within functions, just with a small difference that it calls itself. Now for your easier understanding, all that you need to remember is main is calling some another function which is of the similar name. That's all. So when it calls a main function, a stack frame is created for that new call. So now this is the stack frame, and we will call it as stack frame of main2. So indicates that main function, and this is the second instance of main. Now here again it sees the value of I equals to 5, but before doing that it will load the address of the place from where it was called. So here you can see that this was the address from where it was called, so it will go and load this address program counter equals to 0x8, which is basically an indication that once this function gets over and the stack frame gets destroyed, one should know where do you have to return back to, from where was this particular stack frame called, and this particular return address indicates that you need to go at this place once this particular stack frame is destroyed. Okay, so it first loads the return address of the place from where it was called, and then it creates another variable I, or it sees int I equals to 5, so it goes and create a variable I with the value as 5, and then the process repeats itself. It sees minus I not equal to 0, so it will go and put this as 4, print of I, so it will go and print 4, and then again it sees a main function. Please note, these functions or activation records or stack frames cannot be destroyed because the end of the function is not yet encountered. So it again creates a stack frame for main function. So now this will be stack frame from main, and we'll call this instance 3. Okay, so again it will store the instruction or the return address from where it was called, so that it knows where to go back to once this function gets over. And then again it creates a variable I equals to 5, and if of minus I, so it again changes to 4, and then it again goes and prints 4, and the process again repeats itself. Another stack frame is created when it encounters a main function. It sees I is equals to 5, then I changes to 4, and then it again calls a main function. So I'm just going to write this as stack frame for main 4, and it prints 4, and this process keeps on repeating until we reach the end of the stack. Now here I've shown a smaller stack, but the stack could be larger in size or even smaller in size, but eventually you will run out of the stack because it's a limited memory at the end of the day. And when that happens, it gives a runtime error, which is also called stack overflow. If in a unrealistic world we had a unlimited stack memory, it would have continued on printing 4 infinite number of times. Please note that the function never got over. All the functions were just getting pushed on to the stack, and a stack frame was created for those function instances, and this function never got over. And hence you will see that in this particular question the answer is going to be stack overflow. Now we will go ahead and solve this question with the keyword static and try to understand the difference or what's the difference between both the questions. Okay, now as we remember, static variables are not stored onto the stack. Static variables are stored on the data memory. So I is going to go inside the data memory and not on the stack memory. And also remember, one part of the definition of static variable states that a static variable is initialized only once at the point of declaration. Post that, compiler just ignores any other initialization statement which it encounters for that static variable. Okay, so let's see what does the statement means. So again, a stack frame is created for the first time when it sees main function. Okay, so we will call main1 stack frame. Okay, so now this I does not go onto the stack memory. So if of minus I, so this minus changes this I to 4. Okay, so is 4 not equal to 0? Yes, 4 is not equal to 0. So, and it sees a print statement, it goes and prints 4. And now it sees a main function is called within itself. So what does it do? It first stores the address, return address, where it needs to go back to once this stack frame is destroyed, or once this particular stack frame or this function gets over. So it will go and store the return address, which is 0x08, and we will call it main2 stack frame. Okay, and now once it comes inside the function, it sees static int I equals to 5. What did we say about a static variable? We said a static variable is initialized only once at the point of declaration. Okay, so which means no new instance of I is going to be created, and I is right now value is 4. Okay, so it sees minus minus I, if minus minus I, so it will change this 4 to 3, and then it goes inside the if statement, and then it sees print I. So it goes and prints I, and I's value is right now 3, and then it again encounters a main function. So we will create a stack frame for main instance 3, and it will store the return address where it needs to go back to once the function is over. And then it comes here, again sees the statement, it ignores the statement, if of minus minus I not equal to 0. So I is 3 right now, minus minus would change it to 2, and is 2 not equal to 0? Yes, it is not equal to 0, and it sees a print statement after that. It goes and prints 2, and then it calls main again. So we call the main again, stores the return address, and here this is the 4th instance of main, and this is the stack frame of main 4. So it sees static int I equals to 5 again, and it ignores that statement, and then it sees if of minus minus I is not equal to 0. So I from 2 changes to 1. Is 1 not equal to 0? Yes, it is not equal to 0. So it goes inside the if statement, and then it sees a print I, so it goes and prints 1. And then again we have a main function, so we call main function, creates a stack frame for the main function, for the new main function, comes here, ignores the statement, if of minus minus I not equal to 0. So 1 changes to 0. Is 0 not equal to 0? 0 is not equal to 0 is a false, and it will not enter inside the if, and will straight away come here, which is the end of the main function for the first time. And once the function ends, what it does is it goes and destroys the stack frame which was created for that main function. Okay, and it returns back to the calling address. So where was it called from? It was called from 0x08. Okay, so it comes back. So once the control comes back to this stack frame, it starts executing from 0x08. So it comes here, and the next statement is end of if, and the next statement is end of the main. So even this stack frame is now going to get destroyed. And where does the control go back to? It says 8. So we will destroy the stack frame, and the control now goes back to the main 3 stack frame, where the program counter we saw that had the value 8. So 8 is, so after 8 we get the end of, we will see that we get the end of the if statement, and then we get the end of main. So it will go ahead and now destroy the main 3 stack frame also after loading the program counter where it needs to go back to. So it loads the program counter with PC08 because it's here, and now the control goes back to the main 2 stack frame. So again it starts executing from here, sees the end of if statement after that, and sees the end of main 2. So it will go and destroy the main 2 stack frame as well, and the control goes back to the main 1 stack frame, and the code starts executing from the place where it left, which is nothing but the address 8. So it comes back to the main 1 stack frame, sees the end of the if, sees the end of the main, and finally it goes and destroys even that stack frame, and that's the end of the code. And the output for this question is 4321, which is nothing but option number A. Right, so I hope you understood this question. This question helps you understand a lot of fundamentals in depth. With the small code snippet, you can understand the difference between static variables and local variables. Clearly you can see that how, and you can prove via this question that static variables cannot be stored onto the stack, okay, because every stack frame would have different instances of I, but here in data memory, which is shared between which is shared between the function calls, has only one I which keeps on getting updated, and hence we get a realistic output and not a Stack Overflow error. I hope you guys liked the video. Please do subscribe if you liked the video, and in the comment box below do give your suggestions.